Can you label all the parts of a phase diagram? If you can think of the molecular level and how each phase is structured, that can help you label a phase diagram. Solids, which are highly packed and frozen, exist under low temperature and high pressure in this region in the upper left. Gases, which have a lot of energy and have their molecules far apart and loosely packed, exist under low pressure conditions in this region at the bottom. And liquids, tightly packed but loosely bound, exist somewhere in between. Now that we know what each of the regions are, let's look at the lines between them. These are where the phase changes actually occur. That is, they're equilibria lines where each phase that borders it exists together. For example, at this point, we would see both a solid and a liquid at that temperature and pressure. So, our phase diagram is telling us not only where our phases exist, but where our phase changes occur. For example, starting with a solid and changing the temperature until it becomes a liquid, we get melting as it crosses that line. And starting with the liquid and decreasing the temperature until it crosses that line, it becomes a solid, which would be freezing. Moving between the gas and liquid phases across their line would be vaporization and condensation, and between the solid and gas boundary would be sublimation and deposition. And we're not limited to changing temperature. We can achieve the same changes by increasing or decreasing the pressure instead. That is, instead of moving left to right, by moving up and down. When these transitions happen at 1 atmosphere, we call them normal. They are normally what we experience in our day-to-day. So, looking at 1 atmosphere and drawing a line across where it intersects the solid-liquid line would be our normal freezing point, and where it intersects our liquid-gas line would be our normal boiling point. We see here in the middle there's a point where all 3 of our phase boundaries intersect. That means that since all 3 phases are bordering on that point, all 3 phases can exist at that temperature and pressure. Since that's the case, we call that our triple point. Another point of interest is at the end of our gas-liquid line. While the solid-liquid line will continue indefinitely, this one ends, and it ends at what we call the critical point. Above this point, there is no distinction between the phases of liquid and gas, which is why the line disappears. So, the liquid phase spills over into this region, but so does the gas phase, meaning that in this region we have a new phase that we call a supercritical fluid, that is a fluid above the critical point. It has properties somewhere between a liquid and a gas. Done. Check out the full video for more tips and help on phase diagrams.